Couldn't find a really great math joke on tables, but I found one with a table in it, and they say, "Oh no, remainders again. Get it? Leftovers." But in frequency tables, we'll actually be using all the data points, so we should have no leftovers in our lesson. So why do I make a frequency table? Because this is my goal. When you are doing analysis of data later to determine if something is an appropriate test, we're going to have to do things like make histograms and box and whisker plots to check for things like modality, which I'll go over later in this lesson with histograms, and symmetry. So how do we make a histogram then? Well, the bars represent the data points in each class. The height of the bar represents a number of data points. And classes on a histogram, classes touch. Now, you might be tempted to call this a bar graph, but that's actually not a bar graph. It's a histogram. So to build a histogram, you first build a frequency table that's going to count the data points. Now, go ahead and copy these down. These are data I took from one class of the longest Snapchat streaks, all right? We have 33 data points in here. And from this, what I need to figure out to start my table is the range, how far, what's the lowest? Because if you're graphing it, you need to know how wide your histogram is going to be. So I need to go from 0 to 730 is the high here. I need to know how many bars I'm going to use, or groups or classes. They might even be called intervals. And I need to know the class width. So that's how wide the bar or interval is. So make sure you get all this copied, and then let's go to the next step. So the next step is determining the range, and that's basically first we need the minimum and the maximum. In this case, it's 0 and 730. In a way, I wish we didn't have 0 as our minimum, because then when I subtract them to get the range, it looks like the range is the maximum, but it's not. The range is the difference between the minimum and the maximum. So the desired number of groups or classes, we always like to have, to get some shape to it, you normally wouldn't want to have just 2 bars, right? Because if this, you could have a shape like this, you could have a shape like this, and it's not going to tell you a lot with just 2 bars. If you have 3 bars, that gets a little bit better on shape. 4 is even better, and we actually like 5 bars. Now, if you have 100 data points, you could actually have more bars. So we have a general guideline of the square root of n for that. So square root of 33, we had 33 data points for Snapchats, is 5.7. So we can use between 5 and 6 classes. In this case, we're going to go ahead and just use 5. Our group width is the range divided by the number of classes. Not the maximum, but the range, the difference between the two. In our case, and whatever answer you get, you always round up, even on the extreme, and I'll explain why. So here we have 730 divided by 5 is 146. So you're thinking, oh, I'll just start and make my bars 146 wide. Here's the funny part. If you actually do this for your data and you have 5 bars, you're not going to reach 730. You're going to stop just before 730. So you got to go up one bigger to cover that whole range. Okay, so we're going to use 147. Now, in real life, honestly, I really wouldn't use 147. You're allowed a little leeway, especially in AP Stats. You could go to 150. That makes way more sense. But I'm pretty sure I'm using 147 on this next example. The lower class limit is the lowest data point. So here we're going to have a range of data that's going to go in this group. So this is my first class width or bar. This is my second bar. This is my third bar, my fourth bar, and my fifth bar. Okay. So the lower class limit is usually the minimum, unless your bars are a little wide and you're like, oh, I want to make it look really pretty. You can change what your minimum is. To get the other class limits, you just keep adding the class width. So it's easier to work along this first column here and then not worry about the upper class limits just yet. So let me show you. So here I'm going to add the class width, 147, and I get 147. Add 147, and I get 294, then 441, and 588. I recommend you write that down so you know how to do it. Now, For this piece right here, there are two ways to do it. You can say, well, let me add the class width, but I have to subtract 1. Why? Well, this data is going to include from 0 to what? Well, this data set starts at 147. What's right before 147? It's 146, which, by the way, if I go 147 minus 1, I get 146. Then I keep adding. To get here, it's just a number before 294, so it's 293, 440, 588, that would be 587. And then you're going, wait a second, I have nobody to look at down here, right? Well, if you notice, these are also 147 apart. I can just add 147 to get 734. Okay, so the class boundaries part here is we use it to make the bars touch, all right? That's why we have it there. By the way, this may not represent actual data points, and I'll go over that again. It is also needed if you have continuous data, so if, say, you're weighing, I don't know, fish, and you're doing 0.5 ounces, or 0.7 ounces, or 0.3 ounces, then these class limits won't work because these tend to be integer values. So how do we do this? I'm going to start with this one because this one's a little easier to start with than that first one, all right? So I'm setting these boundaries for this group to 146.5 to 293.5. Okay, why is that? Well, I know that I want the bars to touch halfway between 146 and 147, all right? I also want the bars here to touch halfway between 293 and 294. And that meeting point is 293.5. All right, so usually what happens is the upper boundary for one becomes the lower boundary for the next one. And you can see that 440.5 comes down here, 587.5 comes down here. Now the next one, if you look at this, it's this 0 kind of messes us up. So people tend to get stuck on this very first boundary. And they go, oh, what do I put there? What do I put there? Well, I know that this boundary is going to be 146.5, all right? And how could I get that? Well, I could add 0.5 here to get here. How could I get 146.5 from 147? Well, if I went back 0.5, that would work. So we typically subtract 0.5 for the lower boundary and add 0.5 for the upper boundary, which gives us this kind of weird negative 0.5 to negative 146.5. And you'll only get that weird behavior if you have a 0, which this data does, but not all data does. After you finally set your boundaries, you're going to go ahead and you're going to look at that data that we wrote down, and you're going to count how many fall in the groups. Now, if it's integer data, which Snapchats is not like you do half a snap, it's easier to use the class limits. You say, okay, anyone from 0 to 146, they're in the tally. Oh, by the way, class boundaries do not need to be actual data points, all right? Because we don't have 146.5 Snapchats. So let's start working on the tally. And this represents a total number of data points that are within this bar. So every row in the table represents a bar. If it's exactly on a boundary, then it is put in the next class. So and that's for a boundary, not class limit we're talking about. So if I had decimal data, if I had 146.5, it's actually going to jump here. With integers, we have less of an issue. So you put it in the next higher. So the first group, I'm counting integers because it's easier. That's how many, we had 20 tally marks. So those are just tally marks. And then we have 9, I believe, and 2, 1, and 1. So the total number of tallies is the frequency. And hopefully all of these should add up to 33. It's always a good idea to check it. Now you might be interested, sometimes the bars show class midpoints, and the value is in the middle of these two values. Or you can also use these two. So basically you can average the upper and lower class limits to get the class midpoint. 73 there, 147 and 293 divided by 2, you get 220. Hopefully you'll notice that the distance between these is also your class width. It's 147. All right. And again, I could have done this whole table with a much prettier set of numbers like 150. But that was not the pretty data I got. And I wanted to show it to you with ugly data. So now we're going to go ahead, and this is a frequency table. You don't always have the class of midpoints. That's actually kind of unusual, but I wanted to show them to you. But there's other types of frequencies. So now I'm going to show you a different set of data. This is data that I've already counted. I've already got the tally, so you don't have to like, where are those numbers coming from? They came from somewhere. So a cumulative frequency table is a number of data points in that class and lower. So we're going to take cumulative frequency. So it's everything up to that point. The first row is the same as the frequency, all right? Which means here, this is just 3. This counts all, this would be like test score data here. It's kind of like what we had on that histogram earlier. So here, this would count every score 59 or lower is 3. Now, to get subsequent rows, just add the frequency for that class to the previous. So if I said, how many people scored 69 and lower? Well, it would be these 5 plus these 3. So you go 3 plus 5, it's 8. How many scored below 70? That would be, 79 and lower. That would be the 8 plus 12, 89 and lower, 99 and lower, and 109 and lower. When you get to the end of the table, this should always equal your total frequency for that class. So that's your N. All right. So to find relative frequency, we're going to take the frequency for that row. And it's a little unfortunate that this one's over here. It really goes with this set of data. So let me go ahead and highlight it. So we're going to use this one right here for here. Okay, just to be clear. So we're going to take the frequency there and divide by N, which is this 39. So that's an important number to keep in mind. That's your N. So 3 divided by 39 is 7.7%. You can do relative frequency as percents or as decimal values. In this case, it would be 0.077. Then you have 5 over 39 is 12.8. 12 over 39 is 30.8. 9 over 39 is 23.1. 8 over 39 is 20.5. 2 over 39 is 5.1. Okay, so that's relative frequencies. And if I was doing this and trying to make a circle graph, well, I wouldn't normally do a circle graph with quantitative data, but it's great for telling me what percentages are in each category. And we will need it for what's called an ogive, which I'll get to next. So cumulative relative frequency is kind of like, you know how cumulative frequency is to frequency? Cumulative relative frequency, let me see if I can change my color. We'll go pink. No, we're purple. We're purple. So cumulative relative frequency is really kind of related to cumulative frequency, all right? And it's the total, so it's just a percentage, or you could just, there are different ways to do it. So it's the total percentage of data points in that class or lower. The first row is honestly the same as the relative frequency next to it. So in that case, it's 7.7%. So it's 3 over 39 is this. Now, I'm going to show you two. Then you can say, okay, then this one's going to be 8 over 39, which is 20.5%. 20 over 39 is 51.3%. 29 over 39 is 74.4%. 37 over 39 is 94.9%. 39 over 39 is 100%. Now, a couple things you can notice about this. One is what's going on. Does the frequency ever go down? No, because we're adding the percentages together. In fact, the other way to do this is 7.7 plus 12.8. Guess what? You get 20.5. 20.5 plus 30.8 is 51.3. You better end at 100% on this frequency table, all right?